Now let's do the very last question on the practice exam, question 6. And so as of the time that I'm making this video, we haven't done it in class yet, but the very next class we're going to learn how to do this kind of thing. So we have a function like this, and it's a cubic, and let me draw just a really ugly picture of what it's going to look like. Oh geez, that's a little too ugly. So it's going to look something like this. Okay, that's what cubics look like. And what we're going to do is we're going to find the absolute maximum and absolute minimum values that this function takes between 0 and 3. So that's the question. So it's very easy because all you have to do is find the places where the derivative is 0, okay, and that'll give you the extrema. And then you also need to check the endpoints, because like in this picture it looks like the maximum value happens there, and so okay, so all you have to do is find the places where the derivative is 0 or does not exist. Those are called the critical points, or and check the value of the function at the endpoints. Okay, so those are the relevant values, and so the absolute max will just be the biggest one of those, and the absolute min will just be the smallest one. So let's get started. Alright, so the real work just amounts to taking the derivative and setting it equal to 0. Let me copy the function x cubed minus 3x plus 1 is f of x. Alright, so now all we're going to do is find f prime, set it equal to 0, and solve. F prime of x is 3x squared minus 3. Okay, so we'll find the values that make that 0. Okay, and the reason we want to know the values that make it 0 is because that tells us where the tangent line is horizontal, and those are the points where it's going to have a local extreme, and we're looking for extrema, and so the absolute extreme is just going to be one of the local extremes. So we'll find the local extreme. Alright, so solve this equation. So this means x squared is equal to 1, and so x is equal to plus or minus the square root of 1, which is 1. Okay, alright. So we could look at the picture again, but normally you're not going to have a picture. Alright, you're just going to be doing this purely with symbols, but it's very easy, okay, because we're looking at the interval from 0 to 3. Okay, so all I have to do now is check the value of the function at endpoints and critical points. So critical points are just the points where the derivative is 0 or doesn't exist. Since this is a cubic polynomial, there are no places where the derivative doesn't exist, but don't worry about all those complications. So all we're doing is just checking the value of the function. Okay, so what we need to find is f of 0, f of 3, and f of 1. I don't even have to worry about negative 1 because we're only interested in finding the extremes between 0 and 3. Okay, so 1 is in there, but negative 1 is over here, and we don't care what happens there. So let's check these values. So let's scroll up so we can see the function again. So there it is, and you can see that if you plug in 0, it's 1, right? Okay, so let's go back down here. So this is 1. And what's going to happen if I plug in 3? So go back up to the function. If I plug in 3, I get 27 minus 9 plus 1. Okay, and this is 18, I believe. Alright. So, or is it 19? It's going to be 28 minus 9, and that is 19. 19, right. Okay, so this is 19. Okay, and now let's check what happens at 1. So that one should be easy. You plug in 1, f of 1, you get 1 minus 3 plus 1, and that is minus 1. Okay, so we're done, and you're probably asking, where's the beef? So this is what happened. Alright, so all the local extremes are given here, so we want to find, let's write down the absolute minimum that the function takes on 0, 3. Okay, so it's just going to be negative 1. So I should say is negative 1. And it takes on this value at x equals 1. Okay. And now what about the absolute max on the interval from 0 to 3? So that is clearly 19. And it happens at x equals 3. Okay, so we're done with the problem. And all the work was done by the theorem that we have that says that these are the only values that we need to worry about. And all this jives pretty well with the sketch that I made at first. So you can see that on the interval from 0 to 3, the lowest point is here where the function turns around, okay, where it has that horizontal tangent, and that must be the value 1. So we found that 1 is the absolute minimum. And then it starts to go off, like cubic polynomials are wont to do, towards infinity on the right. And so the biggest value happens here at 3. And I guess I should mention, we're done, but it's good to know that if you have a continuous function and a closed interval, then its minimum and maximum values are actually achieved. And maybe that's completely irrelevant. Anyway, I'm sorry I stole my own thunder and ruined what could have been a very dramatic conclusion to some awesome work on my part in finding that the absolute min is minus 1 at 1 and the absolute max is 19 at 3. And that's the end.